Hello everybody. In this lesson we are going to discuss and learn what is a chemical equation, what are the parts of a chemical equation, and of course how to balance a chemical equation. A chemical equation is important because in chemistry we are going to deal with many chemical equations, okay, and in order to get proper answer, or in order to get for the next step, there must be a balanced chemical equations. When your chemical equation is not balanced, unfortunately you are gonna get a wrong answer by the end. That's why knowing, okay, how to balance a chemical equation is important. So here a chemical equations, we can say, mainly is made up by coefficient, subscript, reactant, product, and plus that is also direction. Okay, simply I can say if A is going to react with B and produce C, the main part is reactant we are going to study, okay, and the products which have been formed by the end of the chemical reaction is called product, okay, or the substance which is formed by the end of the chemical reaction is called product. And of course this arrow, it shows this is the direction. Okay, so before going to start this, we must know also what is subscript, what is coefficient. Okay, here in the next step I have some example to differentiate or to understand what is subscript and what is coefficient. In this example you can see O2. O2, this 2 is the subscript of oxygen molecules. This 2, it shows the number of atoms present in oxygen molecules. This 2, it shows that there are 2 oxygen atoms. We can say there are 2 oxygen atoms. Okay, and it only belongs to oxygen atom. This subscript, it only belongs to what? Oxygen atoms. Okay, so here we have another example, 2NaCl. 2NaCl. This 2 is coefficient and it always present in front of a chemical formula, chemical compound, and this 2 is, it belongs to with all elements which is present in the compound. This 2, it shows the number of molecules. I can say there are 2 sodium chloride molecules. Okay, so here I would like to give one more example. For example, if I say 3H2O, this 3 is coefficient and it shows also there are 3 molecules of water. But here if I say like S8, this 8 is subscript of sulfur and it shows that there are 8 sulfur atoms, okay, in these molecules. Okay, let's go to for the next page. There are more examples. Here also the same example also is that you can see 3 molecule H2O. This 3 is coefficient of this water molecule and this 2 is the coefficient of hydrogen. How about the coefficient of oxygen? It is 1. If it is 1, 1 is not, of course, written. So according to this, for these molecules, what does it mean? This 3, it shows there are 3 molecules of water. It contains 6 hydrogen atoms and 3 oxygen atoms, like this. 3H2O, it means 3 multiple 2, there are 6 hydrogen atoms, and 3 multiple 1, there are 3 oxygen atoms. Now we have another example. In these molecules you can see there is a mistake, of course. It is supposed to be 2, not 3. 2 molecules of iron 2 oxide contains, we can see, 4 iron atoms. Okay, 2 multiple 2 is 4 and 6 oxygen atoms. Okay, so here if I give one more example, if I say like 5SO4, so what you say? 5 is the coefficient of the sulfate molecules. Okay, we will say there are 5 molecules of sulfate. Okay, contains all, have, okay, 5 sulfur atoms, plus, okay, 20 oxygens. Okay, So let's go for the next page. In the next page we have another example, but here we need to be very careful because in this example the subscript is before bracket, okay, before parentheses. If subscript is before parentheses, it means that this subscript it affects all the elements present in the bracket, okay? Like what? Like I can say here two multiple oxygens and two multiple nitrogens, okay? In this case we need to be very careful. There is one atom of calcium, we have only, plus two atoms of nitrogen. As I say, two, it belongs to with those elements which are present in the bracket, and we can see two multiple 3, there are 6 hydrogen atoms. Let me give another example. If I say aluminium 2 in parentheses SO4 3, okay, so what we will say here, the coefficient is 1. One molecule of aluminium sulfate contains 2 sulfur aluminium atoms, okay. How many sulfur atoms? 3 sulfur atoms and 12 oxygen atoms, okay. So another example let me give you. If I say 5 molecule, okay, H2O, 5 molecule H2O, it contains, we will say, unfortunately 5 molecule H2O contains 5 molecule water, 5 molecule water, 10 hydrogen atoms and 5 oxygen atoms, okay. So for the next example, for the next page, my dears, here let's discuss reactant and product, and now I would like to give also some examples to see how a chemical equation is balanced, okay. The question is that why do we balance a chemical equations, or why a chemical equation is supposed to be balanced? According to law of conservation of mass, you know already, you studied this. The mass cannot be created or it cannot be destroyed. It only changes from one form to another form. I mean to say, in a chemical equation, if you have 5 apples, there must be also 5 apples. You cannot destroy it, okay. If you have 2 hydrogen, there must be exactly 2 hydrogen. If you have 3 oxygen, there must be also 3 oxygen. You cannot destroy it or you cannot, okay, create. You can only change it from one form to another form. Here, the formation of sodium chloride, my dears, you can see sodium and chlorines are called reactant. Those elements before arrow or on the left side of the chemical equations, they are called reactant, okay. Those elements on the right side of chemical equations, they are called products, okay. So of course there is direction, as I told you, this is called direction. And also here the state of each element we have to mention, like what? For example, hydrogen plus oxygen, it gives water, okay. So we have to indicate, okay, what is the state of hydrogen at room temperature, what is the state of oxygen, and what is the state of product, and water, okay. Here, my dears, you can see if your product, your element is solid, so you have to put small s. Is there any solid here? I don't think so. If it is gas, it is written as small g. So I know that hydrogen at room temperature, it is gas. So I have to write in bracket like small g. And oxygen also gas, I know. And if it is liquid, so we have to write, okay, like L. So what is aqueous? Aqueous means when your elements or products are dissolved in water or in any solvent, so we call it aqueous, okay. So you may ask, how do we know that the state of elements? Most probably we are going to be familiar with almost all the elements which we study in the class, okay. For example, oxygen, everybody knows that oxygen is gas at room temperature. If there is iron, we know that the iron is solid at room temperature. If there is hydrochloric acid, then we know that it's a kind of acid and it is, okay, aqueous at room temperature. Okay, like this. So let's try to, okay, understand how a chemical equation is balanced. For balancing a chemical equation, first of all, there are 3 steps: 1, 2, and 3. The first step is we are going to write the equations with their symbols, okay, not with their names, with their symbols, okay. And we are going to write what are my reactant, what are my product. After that, we are going to count each element on the left side of chemical equations. It means that what are your products, how many chlorines are there, how many hydrogens are there, how many oxygens are there. And we are going to also write, okay, what you have by the end of the chemical reactions. Means the number of the quantity of each element which is present in the product side. This is product, these are reactant. Then we are going to balance. We can balance chemical equations with playing only with coefficient, my dears. Okay, playing with what? Coefficient. We will never ever touch subscript, okay, you cannot touch. So we can only play with coefficient. You can put 2, you can put 3, you can put 5, you can put, okay, what is required to balance chemical equation we will put, okay. So when we write or when we put any coefficient, we are going to recount all the elements and try to balance it. Here, for example, in these equations, I know that there are 2 chlorine, there are 2 hydrogen. So by the end I have 1 chlorine and 1 hydrogen, and definitely according to law of conservation of mass, this chemical equation is not balanced. Since this chemical equation is not balanced, so what I am supposed to do, I am going to add some number, some coefficients, and in order to balance it. So I can say here I have only, okay, 1 chlorine and 1 hydrogen, and here I have 2 chlorine, 2 hydrogen. So what I am supposed to do, if I put coefficient 2 in front of hydrochloric, okay, in this compound, I am going to make it balance, my dears. When I put 2, you can see after putting 2, let's write once again the equations and recount, okay. Now I have 2 chlorine and 2 hydrogen. I have 2 chlorine and 2 hydrogen. The number of chlorines are equal, number of hydrogens are equals, okay. Now here I would like to give some examples, okay. No, so I would like to give some simple examples, like for example carbon plus oxygen, it is going to give carbon dioxide, and I am going to check. These are my reactant, these are my products, okay. So here I have 1 carbon, I have 2 oxygen. Here I have 1 carbon and I have 2 oxygen. So you can see number of carbons are equal, numbers of oxygen are equal, and this chemical reaction is already balanced. You may not be always that much lucky, because there might be some chemical equations, most probably they are not balanced, so you are the one who has to balance it. So let me give another example. Suppose if I say formation of water, when hydrogen is going to react with oxygen, it's going to produce or give water, okay. So these are my reactant, I can write, these are my product. Here we need to know that always hydrogen, nitrogen, oxygen, okay, chlorine. So these are the elements, they can never ever exist in atomic form, they will always exist in molecular form. This is rule. In the air, hydrogen does not exist as a single atomic form, it always exists in molecular form. Oxygen never ever exists in atomic form, it always exists in molecular form. That's why we have to write as a molecules. Then I am going to write their states. The state of oxygen already we studied in the class, in the lesson, in previous slides. So oxygen is also gas, hydrogen is also gas, and water is liquid, you know. I will put L. Then in order to balance, what I am going to do, first I write down the chemical equation. You can see I already write. Okay, I have already written. Then I am going to count, okay, each elements. 2 hydrogen I have in the reactant side, 2 oxygen. Then I have 2 hydrogen and I have only 1 oxygen. So according to the law of conservation of mass, yes, number of hydrogens are equal, but number of oxygen are not equal. So I have to make it balanced because I cannot create nor I cannot destroy it, okay? So in order to balance, what I am supposed to do? We will never ever touch in subscript, I told you. So we can only play with coefficients. So if I put coefficient here, of course I am going to change also the number of hydrogens. So which number I should put to make oxygens equals? So definitely I am going to put the number of 2. When I put the number of 2, let me write once again. So H2 plus O2 is going to give 2H2O liquid. Okay, so let me write and once again recount 4 hydrogen this time I have, and I have 2 oxygen. This time I have 2 hydrogen and 2 oxygen. So number of oxygens are equal, but number of, you can see, the hydrogen are not equal. So what I am supposed to do? I have 4 oxygens here, 4 hydrogens here, but I have 2 hydrogens here. So what happened? Of course, definitely I am going to come and add the coefficient of 2 here to make it balanced. When I put 2, it will be 4 hydrogens. So now my chemical equation is balanced. Okay. So let me give one more example. So in this example, I can say, okay, suppose carbon plus oxygen, it gives, okay, this is the like incomplete chemical equation due to the less of air, carbon monoxide. Okay, in this situation, what I have, 1 carbon and 2 oxygen. In the product side, I have 1 carbon and how many oxygen I have? Only 1 oxygen. So carbons are equal, but oxygen are not equal. So what I am supposed to do? Definitely, I am going to add coefficient 2 here. If I add coefficient 2 here, let me write once again. Okay, 1 carbon plus O2 is going to give 2CO. So once again, I am going to recount 2 carbon, 2 oxygen. Still, I have 1 carbon and 2 oxygen. So number of oxygen are equal, but carbons are not equal. What I can do, if I put coefficient 2, it is going to be balanced. Now let's go back to our presentations. Okay, in our presentation I have some examples. For example, the formation of ammonia. Okay, for the formation of ammonia, let me do here. I know that when nitrogen and hydrogen combines, they are going to, or when they react, they are going to give ammonia, NH3. So this is gas, or aqueous also you can write, same thing. This is definitely gas, and this is what? Gas. Okay. So this is my equation. So what I am supposed to do, first I will count each element in the both sides. 2 nitrogen and I have 2 hydrogen. I have 1 nitrogen and I have 3 hydrogens. So here what can I do to balance them? Definitely, in order to balance nitrogens, I have to put coefficient here 2. So if I put coefficient 2, I am going to write once again and recount after making any change. Okay, and 2 plus H2 is going to give 2NH3. Then once again I am going to count 2 nitrogen, 6 hydrogen. This time I have 2 nitrogen, and this time I have only 2 hydrogen. So what happened? Number of nitrogens are equal. It's okay. But how about hydrogens? I have 2 in the reactant side. I have 6 in the product side. So what I am supposed to do? Definitely I will come and I will add 3 coefficients. When I add 3 coefficients, my chemical reaction is going to be balanced. Now I have 6 hydrogens. Okay. So in the questions, let me check the next Next one. Our next example is carbon, okay, methane gas is reacting with oxygens. Okay, let me do also here. So methane gas CH4 is going to react with or burn and produce always carbon dioxide and water. Okay, here you can keep in your mind, if any alkane or alkene is going to react with oxygen, our product is always, it will be carbon dioxide and water. Okay, so let's try to balance it. I have one carbon, 4 hydrogen and 2 oxygen. In product side, one carbon, I have 2 hydrogen, and definitely I have 1 oxygen is here and 2 oxygen is here, 3 oxygen. So let's get start, okay, balancing which one? Hydrogens. Suppose if I balance the hydrogens, okay, because carbons are equal, so what I am going to do, if I put coefficient 2 here, it's going to be balanced because I have 2, I have 4. So put coefficient 2 in front of water, okay, then let's recount. CH4 plus O2, it gives CO2 plus 2H2O. Then I am going to count. Now I have one carbon, but I have 4 hydrogen, and number of oxygen, of course, it changed. Now I have 2 oxygen from here. Okay, 2 oxygen from here. Total I have 4 oxygen. In the reactant side, I have 1 carbon, 4 hydrogen and 2 oxygen. So what carbons are equal, hydrogens are equal, and oxygen are not equal? Definitely I am going to put 2 here and it will be balanced. So my chemical equation can be balanced by putting 2 coefficient in front of oxygen and of course 2 coefficient in front of water. So that's all. So you can find many like chemical equation and you can answer. Thank you very much for watching.